So let's dive right into how metformin has been hiding a secret in plain sight for like decades. It's surprising brain action, particularly through a protein called RAP1 in the ventromedial hypothalamus.
Yep. That's so wild. After 60 years of it being the go-to diabetes med, we still didn't know it acted this way?
Exactly. It's like metformin isn't just messing around in the liver or gut, but is also um, cozying up in the brain to, control blood
Mm-hmm.
sugar. They found that suppressing RAP1 in the VMH is really key.
So they even knocked out RAP1 in some mice to see if the effect would vanish, right?
Yeah, it's ingenious. In those genetically modified mice on a high-fat diet, low doses of metformin did nothing because without RAP1, the pathway just didn't
Right.
switch on. And what's even more intriguing is when scientists put super tiny amounts of metformin directly into the brain, it like massively dropped the blood sugar levels.
Wow, so the brain basically reacts to doses that are like thousands of times lower than the usual amount given orally?
That's right. It really challenges the old school thinking where we mostly looked at the liver and the gut. It turns out that SF1 neurons get activated by metformin when RAP1 is around, which is essential for that glucose lowering effect.
Absolutely. I have to ask though, isn't it a bit counterintuitive that such a tiny dose in the brain can make such a difference compared to the higher amounts required in, the liver?
Yeah, that's a fair point. I mean, it's like the brain is way more sensitive to metformin, which might explain why the drug has additional benefits like slowing brain aging.
Mm-hmm.
It suggests that there's a whole untapped potential here for, more precise diabetic treatments.
And speaking of precision, isn't it interesting that other diabetes drugs, like insulin, still work normally in these modified mice? That clearly pinpoints the specificity of this brain pathway with metformin.
Exactly. And it really narrows down the action to this RAP1 mediated mechanism. What's cool is that while the liver needs those high, almost overwhelming doses, the brain is doing its job with a whisper.
Yep. I do wonder though, could there be potential downsides to targeting the brain like this? Some people in the comments mention side effects like vision issues or even cognitive problems from metformin.
That's a solid critique. While the brain pathway opens up new avenues, there's also a need to really monitor long-term effects as it might interact with other neural processes. After all, metformin's benefits are a two-edged sword.
Mm-hmm. It almost feels like we're just scratching the surface. This could mean revisiting how we manage or even formulate the drug in the future, right?
Absolutely. This work could lead to more targeted therapies that harness the power of the brain without the side effects we worry about today. It's like opening a new chapter after 60 years of mystery.
Right. And with everyone's passion on the comments about drug safety and alternative therapies, it's clear that this research not only has implications for diabetes, but also fuels the broader debate on drug design and patient care.
Exactly. It's a significant leap forward, and the implications extend way beyond just one drug. It's a reminder that sometimes the best answer is hidden in unexpected places, like our brains.
Mm-hmm. Fascinating stuff. Ready to see where this new angle takes us in the fight against diabetes?
Oh, for sure. Thanks for the chat. It's been a real eye-opener digging into the hidden layers of metformin's action.
Absolutely.